This is the EdExcel GCSE 91 Maths Foundation Paper 1 from the Specimen Set 1 papers, and this paper is a non-calculated paper. Question number 1, we have to change 530 centimeters into meters. Well, to go from centimeters to meters, we would have to divide by 100, and meters to centimeters, we would have to multiply by 100. And therefore, if we work out 530 divided by 100, we would get 5.3, and therefore 530 centimeters is the same as 5.3 meters. Question number 2. How many minutes are there in 3¼ hours? Well, we know that in 1 hour there are 60 minutes. And so in 3 hours there will be 3 times as many minutes, which is equal to 180 minutes. And in 1/4 of an hour, dividing by 4, we can see that there are 15 minutes. And therefore, in 3¼ hours, there will be 180 minutes plus 15 minutes, which is 195 minutes. Question number 3, we have to write 4.4354 correct to 2 decimal places. Well, if I draw a number line, when we write our number correct to 2 decimal places, our lower bound will be 4.43 and our upper bound will be 4.44. Our halfway point is 4.435. And because our number is here somewhere, we would have to round up to the 4.44. Question number 4, we have to write 0.9 as a percentage. Well, 0.9 as a fraction, because we've got 1 digit after the decimal point, our fraction will be out of 10. So here we've got 9 out of 10. And so, to convert to a percentage, we need our fraction to be out of 100. 10 times by 10 is 100, so 9 times by 10 is 90. We've got 90 out of 100, which is the same as 90%. Question number 5, we have to work out -3 all cubed. Well, what this calculation is the same as is -3 times -3 times -3. Minus 3 times minus 3 is 9. Timesing that by minus 3, we get minus 27. Question number 6. Here are 4 cards. There is a number on each card. We've got 4, 5, 2 and 1. For part A, we have to write down the largest 4-digit even number that can be made using each card once. Well, if it's an even number, the number must end in either the 4 or the 2. Now we want the largest 4-digit even number. Now the largest number here is 5, so 5 will go in the thousands column, followed by the 4, followed by the 1, followed by the 2. This is the largest even number, which is 4 digits, that can be made using these cards. For part B, we have to write down all the 2-digit numbers that can be made using these cards. Well, we could have the 4, the 5, the 4 with the 2, or the 4 with the 1. Or we could have the 5 with the 4, the 5 with the 2, or the 5 with the 1. Or we could have the 2 with the 4, 2 with the 5, and 2 with the 1. Or we could have 1 with the 4, 1 with the 5, 1 with the 2. Here are all the possible numbers we could make that are 2 digits. Question number 7. The table shows information about the sports some students like best. We have to draw a suitable diagram or chart for this information. What we can do is draw a bar chart. Now, we've got hockey, tennis, football and golf. So what we'll do is we'll add those on. So that's what we see here. Now, adding on our vertical scales, well, the biggest number we've got is 15, and we've got here 1, 2, 3, 4, 5, 6, 7, 8 full squares. Now, each full square can represent 2. So if I start off at 0 here, we've got 0, 2, 4, 6, 8, 10, 12, 14, 16. And now we've got information for boys and girls. Now, what we need to do before anything else is actually make a key. Well, if we said the blue is boys and the red is girls, well, what we can see for hockey, we've got 3 boys, 6 girls. For tennis, we have 8 boys and 14 girls. For football, we have 15 boys and 7 girls. And for golf, we've got 9 boys, 1 girl. Question number 8. Bernard says, when you have a whole number that ends in 8, you always get a number that ends in 4. And for part A, we have to write down an example to show that Bernard is wrong. Well, if I have 18, the 18 ends in an 8, we get 9. And the 9 here does not end in a 4. So here we have shown through an example that Bernard is wrong. Then for part B, Alice says, because 7 and 17 are both prime numbers, all numbers that end in 7 are prime numbers. Is Alice correct? You must give a reason with your answer. Now let's think of the number 27. 27 we can write as 9 times by 3, which we can see is not a prime number. In fact, what would be easier would be to show the factors of 27. We've got 1 and 27, 3 and 9. So what we can see then is the 27 has factors other than 1 and itself, so 27 is not prime, and therefore Alice is incorrect. Question number 9, we have to work out 247 times 63. Well, here we can use the grid method. The 247 we can rewrite as 200 plus 40 plus 7, and the 63 we can rewrite as 60 and then 3. So now let's multiply. 60 times 200 is 12,000. 60 times 40 is 2,400. 60 times 7 is 420. 3 times 200 is 600. 3 times 40 is 120. 3 times 7 is 21. So now we have to add all these together. So we've got 12,000, 2,400, 420, 600, 120, and 21. All this is being added together. So here we've got 1, 2 plus 2 plus 2 is 6, 4 plus 4 plus 6 plus 1 is 15. So then we carry the 1 here. 1 plus 2 plus 2 is 5, and then we've got the 1 over here. So our resulting answer is 15,561. Question number 10. An American airline has a maximum size for bags on its planes. Width is 14 inches, depth is 9 inches, and the height is 22 inches. And Chris has a bag. It's got a height 50 centimeters, a width 40 centimeters, and a depth 20 centimeters, and 1 inch is equal to 2.54 centimeters. Can Chris take this bag on the plane? He must show you working. Well, here is a diagram of his bag. What we've got is the width being 40 centimeters. So that would correspond to this. Then we've got the depth being 20 centimeters. That would correspond to this. And then we've got the height being 50 centimeters, as we see here. So what we need to do is find out if this fits in this guideline. And we are given that 1 inch is equal to 2.54 centimeters. Well, we can approximate this as 1 inch is approximately 2.5 centimeters. So now let's think about the height. What we can do is convert the height into the inches by dividing by 2.5. So if I've got 50 divided by 2.5, I get 20 inches. The maximum height we can have is 22 inches, so this is fine. If we think about the width, well, the width we have is 40, and if I do 40 divided by 2.5, we get 16 inches. We can have a maximum of 14, So this is too big in the width. And if we think about the depth, we've got a depth of 20. So if I do 20 divided by 2.5, I would get 8 inches, and the 8 inches is less than the 9 inches, so the depth is fine. So what we can conclude then, as the width is too big, the bag is not allowed on the plane. Question number 11, we have to complete the two-way table. Well, if I think about how many boys I've got in total, I've got 12 of them. 5 have blue eyes, 4 have green eyes, and therefore the number of boys with brown eyes, 12 take away 4 take away 5 is 3. If I find out the total number of girls, 30 people in total take away the 12 boys, that will be 18, so we have 18 girls. The total number with brown eyes, 3 plus 7, that's 10. The number of girls with green eyes, well, 9 take away 4, that's 5. To find out the number of girls with blue eyes, 18 take away 5 take away 7 is 6. To find out the total number with blue eyes, 5 plus 6 is 11. Here is the completed two-way table. Question number 12. There are 28 red pens and 84 black pens in a bag. We have to write down the ratio of the number of red pens to the number of black pens. Give your ratio in the simplest form. Well, we've got the ratio red to black being 28 to 84. And if I divide through by 28, we will get 1 to 3. Question number 13. Here is a sequence of patterns made with grey square tiles and white square tiles. We've got pattern 1, 1 white, 3 grey, pattern 2, 2 white, 4 grey, pattern 3, 3 white and 5 grey. And in the space we have to draw pattern number 4. Well, here will be pattern number 4. We would have 4 white, and then we would have 1, 2, 3, 4, 5, 6 grey. And then for the next part we have to find the total number of tiles in pattern number 20. Well, how many tiles do I have for pattern number 1? Well, I've got 4 of them. For pattern number 2, I've got 1, 2, 3, 4, 5, 6 of them. For pattern 3, I've got 1, 2, 3, 4, 5, 6, 7, 8 of them. So what we need to do is find the nth term. So what you can see is we add 2 each time. So I would have a 2n. And then if I do the inverse of adding 2, which is to subtract 2, I would have 2. So my nth term is 2n plus 2 for the total. So when n is 20, pattern number 20, the total is 2 times by 20 plus 2. So what I have is 42. Then for part C, we have to write an expression in terms of n for the total number of grey tiles in pattern number n. So if I look at the number of grey tiles, I have 3 here, 1, 2, 3, 4 here, 1, 2, 3, 4, 5 here. So what's happening is I'm adding 1 each time. So I have n And then the 0th term will be 2, because 2 plus 1 gives a 3. Rather, I'm adding 2. So here is the total number of grey tiles, n plus 2. Question number 14. A unit of gas costs 4.2 pence. On average, Ria uses 50.1 units of gas a week. She pays for the gas she uses in 13 weeks. For part A, we have to work out an estimate for the amount Ria pays. Well, 1 unit of gas costs 4.2 pence, which is approximately 4 pence. And what she does is she uses 50.1 units of gas a week, which is approximately 50 units of gas per week, and she pays for the gas she uses in 13 weeks. So therefore, approximation for the amount she pays, well, what we would have is 50.1 times 4.2, and this is per week, and then I'm going to times this by 13. So what we have here is the amount she has per week, and so we've got 50 times by 4 times by 13. So 50 times by 4, that's 200. So we've got 200 pence times by 13, which is equal to 2600p, or £26. So we end up with £26. And now we have to think whether we've got an overestimate or an underestimate, giving a reason. So because we've rounded down, we've got an underestimate. Question number 15. This is a scale plan of a rectangular floor, and the diagram is drawn accurately. We've got the scale 1 centimeter represents 2 meters, and Mrs. Bridges is going to cover the floor with boards. Each board is a rectangular in shape. Each board is 1.2 meters long and 1 meter wide. Mrs. Bridges has 150 boards. Does she have enough boards? You must show how you get your answer. So what we need to do first of all is measure this. What we've got is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll call it 11 centimeters. So here we've got 11 centimeters, and here we've got 1, 2, 3 and a half. We'll call it 3.5. Now what we can do with this information is find out the real length. So if 1 centimeter represents 2 meters, we need to multiply these by 2. So here I've got the real length being 7 meters this way, and here we've got 22 meters this way. And if we think about how big the board is, well, we've got our board 1.2 meters by 1 meter. And what we need to do is find out how many of the boards would fit across. So what we need to do is find out how many of the boards would fit across and how many boards would fit upwards. like so. So that's what we need to do, and then we can find out the total number of boards by multiplying how many fit lengthways and widthways. So to do that, well, if we think about the width, then what we have is 7 meters, and we need to divide this by the 1, which is 7. So we can have 7 boards going upwards essentially, and in terms of the length, what we would have is 22 divided by 1.2. So if I work this out, this is the same as 220 over 12, and let's see if we can simplify this. So we've got 22, rather if I half it, I've got 110 over 6, half that again, we get 55 over 3. And can we simplify 55 over 3? No, we can't, but what we would get is 18 holes and 1/3 left over. So we'll say that we'll get 18 boards going across. So to find out how many she needs, we would have 7 times by 18, which is 126 in total. This is less than the 150 which she has available. So does she have enough? Yes, she has enough. Question number 16, we have to work out the area of this compound shape. And the way to do this is to actually split the shape up, as we see here. And we can call this area 1 and this area 2. Now here, for area 1, we would have 10 by 2, which is 20 centimeters squared. And for this second area, well, this length over here will be 8 take away 2, which is 6 centimeters. So we would have 6 multiplied by 2, which is 12 centimeters squared. And therefore, the area is equal to 20 plus 12, which is 32 centimeters squared. Question number 17. We have to rotate this triangle by 90 degrees clockwise about the origin. Well, if I trace over these points, I want to rotate 90 degrees clockwise. So I'd have something which lands over here. So here is our rotated shape. Question number 18. There are 500 passengers on the train. 7 over 20 of the passengers are men. 40% of the passengers are women. The rest of the passengers are children. We have to work out the number of children on the train. So the number of men, that will equal 7 over 20 times by 500. So if we work this out, well, we can rewrite the 20 on the denominator, and on the numerator we'd have 35. So we've got 35 over 100 times by 500, and recognizing that 500 over 100 is 5, we have 35 times by 5, which is 175. There's 175 men. And for women, that will equal, well, we've got 40% of 500, and 40% is the same as 2/5. So we've got 2/5 of 500. 500 divided by 5 is 100. So I've got 2 times by 100, which is 200. There's 200 women. So the number of children, we would have 500 subtract the 175 men, subtract the 200 women, so the number of children is 125. Question number 19. A shop sells milk in 1 pint bottles and 2 pint bottles. Each 1 pint bottle of milk costs 52p. Each 2 pint bottle of milk costs 93p. Martin has no milk. He assumes that he uses on average 3/4 of a pint of milk each day. Martin wants to buy enough milk to last for 7 days. The party, we have to work out the smallest amount of money Martin needs to spend on milk. He must show you working. So he uses 3/4 of a pint per day, and he's using this for 7 days, which means per week he uses 21 over 4 pints per week. Well, what we'll do is we'll work this out as an improper fraction. So we would have 5 and 1/4 pints per week. So that's how many pints he uses per week, which means he would have to buy 6 pints in total. Now we want the cheapest way of doing this, and the cheapest way we can do this, well, we can buy 3 2-pint bottles. So the cost of this will be 3 multiplied by 93p. So it turns out we get 279p, which in pounds is £2.79. So we've got 279. Then Martin actually uses more than 3/4 of a pint of milk each day. We have to explain how this will affect the amount of money he will have to spend on milk. Well, if he uses more milk, he would have to buy more milk, which means he would have to spend more money. Question number 20. The diagram shows a right-angled triangle and all the angles are in degrees, and we have to work out the size of the smallest angle. Well, what we know is that angles in a triangle add up to 180. So we've got 7x plus 5x plus 18 plus the 90 degrees, and it turns out this is equal to 180. So 7x plus 5x is 12x. 18 plus 90 is 108. 12x plus 108 is equal to 180. Subtracting 108 from both sides, we will find 12x to equal 72, which means x is equal to 6. So this angle here will equal 7 times by 6, which is 42. The angle here is 90 degrees. The angle here is equal to 5 times by 6, which is 30, plus 18, which is equal to 48. The smallest angle, therefore, is 42 degrees. Question number 21. A box exerts a force of 140 newtons on a table, and the pressure on the table is 35 newtons per meter squared, and we are given that pressure equals force over area, and we have to calculate the area of the box that is in contact with the table. So we've got the pressure 35, and this is equal to 140, which is the force, over the area. We'll call the area A. And what we need to do is find out what A is. So A will equal 140 divided by 35. So it turns out A is equal to 4. So we have 4 meters squared. Question number 22. There are only red counters, blue counters, green counters and yellow counters in a bag. The table shows the probabilities of picking at random a red counter and picking at random a yellow counter. The probability of picking a blue counter is the same as the probability of picking a green counter. We have to complete the table. Well, if I call the probability of blue x, that means the probability of green is also x. And what we know is probability adds up to 1. So I've got 0.24 plus x plus another x plus the 0.32. This is all equal to 1. 2x plus 0.56 is equal to 1. 2x is 0.44, which means x is 0.22. So I've got 0.22 for blue, 0.22 for green. For question number 23, a pattern is made using identical rectangular tiles, and what we have to do is find the total area. Well, what we can do is, suppose that here the length of the rectangle is L. So I've got L here, and I would have L here. And I also know the width, let's call it W. So I've got W here and W here. Now if I take a look at this entire length, I would have L, L and W being added together to give 11. So 2L plus W equals 11. And what I also know is L plus W equals 7. So if I call this equation 1 and this equation 2, because the W's are the same, we can subtract the equations. So if I do equation, I can do equation 1, subtract equation 2, 2L take away L is 1L, W take away W is 0, 11 take away 7 is 4, L is 4, and when L is 4 we can find out what W is. We've got 4 plus W equals 7, which means W equals 3. So now let's draw out a rectangle. We've got the length, which is 4, the width, which is 3, so the area will be 12. So the total area, that's equal to 4, because we've got 1, 2, 3, 4 identical rectangles, multiplied by the area of one of those rectangles, which is 12. So we have 48 centimeters squared. Question number 24. The diagram shows a sandpit. The sandpit is in the shape of a cuboid. Sally wants to fill the sandpit with sand. A bag of sand costs £2.50. There are 8 litres of sand in each bag. Sally says the sand will cost less than £70. We have to show that Sally is wrong. First of all, we can find out the volume. The volume is equal to 40 times 100 times 60, which is 240,000 centimeters cubed, and dividing this by 1,000, we get 240 litres. Now we know that there's 8 litres of sand in each bag, so what we can do is find out how many bags we need. 240 divided by 8 is equal to 30, so we require 30 bags. And therefore the cost in this case, we would have 30 multiplied by £2.50, which is 75. And this is greater than the 70, which is what they claimed, and therefore Sally is wrong. Question number 25. 4 friends each throw a biased coin a number of times. The table shows the number of heads and the number of tails each friend got. The coin is going to be thrown one more time, and what we have to do is think about which of the 4 friends' results will give the best estimate for the probability that the coin will land on heads. Well, how many trials would Ben have? Ben would have 34 plus 8, which is 42. Helen would have 66 plus 12, which is 78 trials. Paul would have 80 plus 40, which is 120 trials. Sharif would have 120 plus 40, which is 160. So, who will give the best estimate? Well, that will be the one with the most trials, which is Sharif. So it will be Sharif because he had the greatest number of throws. Next, Paul says, with this coin you are twice as likely to get heads as tails. Is Paul correct? Justify your answer. Well, the way to think about this is to think about each person in turn. If we think about Ben, Ben has 34 heads and 8 tails. If we think about Helen, Helen would have 66 heads, 12 tails. If we think about Paul, Paul has 80 heads and 40 tails. And if we think about Sharif, we can see Sharif had 120 heads and 40 tails. So what can we say about this then? Well, so we see the proportion of each person getting heads to tails is different. That's what we see here, and therefore Paul is incorrect. Next, the coin is to be thrown twice. We have to use all the results in the table to work out an estimate for the probability that the coin will land on heads both times. Well, how many in total do we have for heads? 34 plus 66 plus 80 plus 120 is equal to 300. 8 plus 12 plus 40 plus 40 is equal to 100. In total, we have 400. So, the probability of obtaining a head is equal to 300 over 400, which is equal to 3/4. And therefore, the probability of getting a head twice is equal to 3/4 times 3/4, which is equal to 9 over 16. So the probability of getting a head twice is 9 over 16. Question number 26. For part A, we have to write down the exact value of cos 30. Well, that will equal square root 3 divided by 2. For part B, we have a triangle here, x centimeters, 12 centimeters, and 30 degrees. And given that sine 30 is 0.5, we have to work out the value of x. Well, sine of an angle is defined by the opposite, which in this case is x, over the hypotenuse, which is 12. So, if we were to find out what x is equal to 12 times by sine 30. So I've got 12 times by 0.5, which is 6. So we have 6. Question 27, we have to expand and simplify x plus 3 times x minus 1. Well, x times by x is x squared, x times by minus 1 is minus x, 3 times by x is 3x, 3 times minus 1 is minus 3. So we end up with x squared plus 2x minus 3. So I've got x squared plus 2x minus 3. Question 28, we have to factorise x squared minus 16. Well, here we've got a difference of two squares. And so if I factorise, I would have x plus 4 times x minus 4. Question number 29, we have to solve the simultaneous equations 4x plus y equals 25 and x minus 3y equals 16. Well, if I call this equation 1 and this equation 2, we can get the y's the same, ignoring any signs. So if I times 1 by 3, what we will have, 4x times by 3 is 12x, y times by 3 is 3y, 25 times 3 is 75. We'll call this equation 3. And then we've got equation 1, x minus 3y equals 16. Now, because the y's are the same, but we've got opposite signs, what we would have to do in this situation is add the equations together. So I need to work out equation 3 plus equation 2. 12x plus x is 13x, and 75 plus 16 is 91. To find out what x is, I would have to divide both sides by 13. And so 91 divided by 13, that's 7, which means x is equal to 7. So, when x is equal to 7, we can substitute this back into equation 2. We've got 7 minus 3y equals 16. And so we see that 3y is equal to minus 9, and dividing both sides by 3, we will find y to equal minus 3. So we have x equals 7, y equals minus 3.